GhanaSongs.org.
Hi, you are welcome once again to the SmartWay lectures on the Science Ambassador series. This is a series of lectures we are running in chemistry, and today we are going to take one of the main standing topic in chemistry as organic chemistry. We are going to take one of the main topic in chemistry, organic chemistry, and we are going to really delve deep into this concept. Now, don't forget to subscribe to our YouTube channel for more exciting videos that we'll be bringing your way. We'll be uploading these videos on YouTube, so subscribe and get more of these videos. Now, let me continue. Organic chemistry. What is organic chemistry? Simply put, before you can understand organic chemistry, let's take our body and split it into two. Take our body and split it into two. Now, the bone, the water, the CO2, and the carbon dioxide, including some few mineral salts that are in us, all constitute inorganic. Now, our hair, our flesh, and our blood, and almost all the cell and the enzyme are organic. So you would see that the body is divided into two: the bone, the water, the CO2, the carbon dioxide, and the oxygen gas, with some few mineral ions in us. When we separate that aside from the hair and the flesh, including the blood and the cells in the blood, that is the red blood cells and the white blood cells, and hormones, they constitute organic. And so we are divided into two: the inorganic part and the organic part. And so chemistry, there are two main standing divisions in chemistry, and these are one, organic and inorganic, and that is what our body comprises of. So our body comprises of organic and inorganic. So when we say organic, what do we mean by organic? And when you say inorganic, what do we mean by organic? Now, all these name just come from a simple thing. Basically, it's just one thing, just an element that separates the organic and inorganic. It's just an element that separates organic and inorganic. And so, what is this element? In the periodic table, you have large group of elements that we have discovered. We have discovered almost over 100 elements in our periodic table, and out of which Lawrencium become the last one, and which still some are yet to be discovered to fill in the gap. So there are a lot of elements in our periodic table, but as I said, the main thing that separates organic and inorganic is carbon. The main thing that separates organic and inorganic is carbon. Why all these elements in the periodic table, that is hydrogen, helium, zinc, copper, sulfur, why all these elements in the periodic table and only carbon? Why have we separated this by just this element, carbon? Now, carbon is very, very important, very interesting element in our periodic table. Its chemistry makes us to set aside, a different chemistry of it. And so carbon is one of the most interesting elements in the periodic table. Let me tell you that carbon is one of the most chemically active elements in our periodic table. Chemically active. I'm not saying that they are chemically reactive. I'm saying they are chemically active elements in our periodic table. And so a branch of science has been set aside to study carbon and to study carbons, that is, to study compounds that basically contain carbons. And so this division in chemistry, this aspect of chemistry, is what we call organic chemistry, and that is what we are going to do today. So there are so many elements in the periodic table, but carbon has made chemists to set it aside, has made chemists to sit down to set its chemistry aside from all the other elements in the periodic table. Now, I will tell you why carbon has been set aside. Why a main division in science, okay, is basically studying carbon compounds. Why is that? I will tell you very soon. Now, so there are two main divisions, organic and inorganic, and as I've splitted my body out and I've told you those things that are organic and those that are inorganic, what makes carbon the most interesting element in a periodic table? I said it already, because it's one of the most chemically active elements in the periodic table, and I'll still ask you why. Now, this is the first reason. When you look on the periodic table very carefully, you would realize that carbon is in the middle. Carbon is in the middle. That is the middle. Carbon is in the middle. Now, its position on the periodic table makes it very interesting. So that is point number one. Its position in the periodic table makes it very interesting. Now, so that is point number one. Its position, because it's at the midway in the periodic table, and the first element at the midway in the periodic table. So it makes it very interesting. Now, though there are other elements, in the middle, that is carbon, silicon, germanium, and coal. Okay, carbon is the first one that comes out of that, so it becomes very special. Carbon becomes very special. Now, again, the other point I want you to also know is that when you look at the electronic configuration of carbon, you would see that when you write its atomic number is 6, and so you will see that the electronic configuration becomes 2 in the inner shell and 4 in the outer shell. Now, you would know that for the outer shell, that is the second shell, and any other shell that is above this, takes a minimum of 8 electrons to make it stable, to make them stable. And so any electron that is 8 on the outer shell, okay, makes the atoms to have some minimum stability. Okay, now, but when you look carefully, you would realize that the electronic configuration for carbon is 2 and 4. And 4 is half of the 8. 4 is half of the 8. And if you are half of the 8, if you need 8 to be stable and you're half of the 8, aren't you half stable? And so that is one of the reasons why. And that is the reason why carbon, okay, has a very interesting chemistry. So its 4 outermost electrons, making them half stable, makes them to have unique chemistry. So the uniqueness of carbon because of the 4 electrons on the outermost shell. It is very important. I said the first one as what? Because it's in the middle, the first element in the middle in the periodic table. And the second point is that it has 4 electrons on the outer shell, making it half stable. It's very important. Now, because of the 4 electrons on the outer shell and its position on the periodic table, it is able to form 4 bonds around itself. And so, because it's able to form 4 bonds around itself, carbon is considered, okay, very unique in chemistry. Carbon is considered very unique in chemistry. So these are the characteristics of carbon that makes it to have an interesting chemistry, that makes it unique for us to set a branch aside to study this element. And so these are the characteristics, and this is why we have separated them. 1, its position on the periodic table. 2, its 4 outermost electron, making it half stable. 3, its ability to form bonds around itself. Now again, let me tell you that carbon is one of the elements in the periodic table that can bond with itself in a continuous chain. Now, carbon is one of the elements in the periodic table that can continuously bond with itself in a very long continuous chain. The process by which this take place is called catenation. So the ability of an atom to bond with itself is what we call catenation, and carbon has this excellent ability of continuously bonding with itself to form a long, straight or branch chain. So it makes carbon very unique. The carbon has the ability to catenate and can catenate more than any other element in the periodic table. When sulfur or silicon try to bond with itself, when it gets to a certain number, it becomes brittle. That is, it easily break because they do not have this unique ability. So carbon has this unique ability to continuously bond with itself without any breakage, without it being brittle, without it being able to break. And so that is one thing that makes carbon very, very unique. And so the last point I want to add is that because of its position in the periodic table, the ionization, the electron affinity, and all the periodic properties are in a midway, and neither too high or low. Neither too high or low. For example, the ionization energy are not too high and also not too low. The electron affinity are not too high and also not too low. The electronegativity are not too high or too low. So all the periodic properties, almost all the periodic property, the nuclear and the effective nuclear charge are not too high or low. And so because of this property not being too high or low, it makes carbon very interesting element in the periodic table. It makes carbon very interesting element in the periodic table. This will end this video, and in the next lecture we will be looking at the two methods that we use to identify any element in organic compound and how these elements are estimated in any organic compound. In the next lecture, we'll be looking at the methods that we use to identify any element in the periodic table and how much of these elements are there. For instance, if I take a sample of your head, which I have now confirmed that it is organic because it's protein in nature and it is carbon that is the backbone, how then do we confirm? How then do we test that this carbon is inside our hair and this hydrogen is inside our hair? In our next lecture, we'll be looking at the two main methods, both the qualitative method and the quantitative method. Follow me, let's do this. Thank you.
The Donald Sports